And go.
Hello, Dr. Loff. This is group 1 or 2, whichever group we are. William Simmons and David Wright, who is the photographer. We are presenting our Tic Tac Toe project for you. First, we're going to go over the software and what the code will be doing behind the scenes. This program is going to initialize an LCD and all the variables that we have inside that is going to be behind the scenes. Then it will jump to allowing the first player to select which color they wish. Push button 1 will allow them to select red, where push button 2 will allow them to select green. Once that color is selected, it goes to the move handling part of the code, which is all the game logic. Whenever push button 1 is pressed, it will increment the row by 1, and when push button 2 is pressed, it will increment the column by 1. If push button 3 is pressed, it will select that position. Once the select button is pressed, it will check to see if that position has already been taken. If it has, it will say it will let the user know that it was an invalid move and allow them to restart their move at the current position that their selector was at. If a valid move is taken, the game will then go into a check for if it is a tie game conditions. If it is a tie game, the game will end and it will display on the display. Otherwise, it will check for victory conditions, and if victory conditions are detected, it will display which player has won and also show a tally of which player has won how many games. After that, if no victory conditions are detected, it will go to the next player's move and the cycle will repeat until the game is over. Now, David is going to describe some of the hardware behind the scenes.
Okay, of course we start with the 68HC11, and we are utilizing multiplexers to basically take the code and decode it so that it illuminates each individual LED. We have one multiplexer over here which drives all the red LEDs, and then we have the other multiplexer which drives the green. And depending on which player it is, it'll jump between each multiplexer. We also had to invert each one because outputting would initially output at high for everything, so we had to invert everything so that we had the correct logic. For each push button, we also had to use pull-up resistors plus also invert them so that it would work correctly. Let's see here. Everything else seemed to fall in place pretty easily. We're going to run a quick routine here and show you some of the outputs on the LCD screen that we have loaded in our table. So what we're going to do is we're going to hit push button 1, and we're going to select push button 1 for red or 2 for green. So I'll go ahead and hit push button 1, and that's signifying that player 1 has now been selected. And this signifies what row and what column we're currently at. So I'm going to go ahead and press push button 3, which is our selection button. And now the first row and first column of player 1 is illuminating red.
Now player 2 takes over, and as you can see, it says player 2 move on the screen and also has row 1 column 1 as the indicator. If I press push button 3 to select that position, it says invalid move. However, if I move my indicator over to row 2 column 2 and press push button 3, now the green LED is lit in the row 2 column 2 position. And because no victory conditions or cat scan was not detected, player 1 takes over again.
So I'm going to go ahead and select another row and column that has not been used. So I'll go to row 2 column 1 and hit push button 3 to select, and again it is illuminating row 2 column 1. And now let's jump back to the second player for them to move to their location.
Now I'm going to simulate the game. I'm going to lose the game on purpose to show what happens during victory conditions. So I'm going to go ahead and select row 1 column 2 and select it. So now those 4 are lit up, and David will select the top row of column 1 to show what happens whenever victory is achieved.
So I go ahead and press the selection button, and then
it says player 1 wins 1, player 2 wins 0.
and then it resets back to start conditions. So now nothing's illuminated, which is a blank screen, and now you have to input which player you want to.
Player 1 starts over again.
Player 1 starts
It's
over
red.
again. Yeah.
So now we're going to show what happens whenever player 2 wins, and we're just going to move the rest of this very quickly. Player 1's move will start at row 1, column 1. Player 2 moves at row 2, column 2. Go ahead and zoom in on the board itself.
Okay.
Player 1 moves at row 2, column 1. If I go to row 3, column 3 on red, go over there, and then row 3, column 2 for green. Whenever I hit this, it will display player 2 wins, and they are now 1-1.
Yep.
Now we will demonstrate what happens whenever there is a tie game. Start off again with player 1. Okay, and now every space on the board is about to be lit. It's player 1's move, and there's only one space remaining. So I move to row 3, or excuse me, row 2, column 3. Select the button, Cat's Game, and neither of the game win indicators are lit. So that is our project. Hope you enjoyed it. And I know it's a bit of a late warning, but please do not allow epileptic people to watch this video.